Hello everyone, welcome to Maths Easy. Today we are going to do a question on bond energy calculations. This is a very popular GCSE chemistry exam question. Seen this question, similar questions with different numbers multiple times. So please pause the video and try the question yourself. When you are ready to check the answer, you can continue the video and compare your answer with mine. If you have any doubts or questions, you can always put them in the comment section. Methane reacts with oxygen to form carbon dioxide and water. The equation is CH4 plus O2 gives carbon dioxide and water. Hang on, this is not balanced. So the first thing we need to do is balance it. Now this is where some students go wrong. I've seen this multiple times. Students do everything else right, but forget to balance. So if that's the case, unfortunately, you will not get the right answer. So let's do the balancing here. There's one carbon here, one carbon here. Carbon is okay. There are 4 hydrogens on the left-hand side. So to get 4, obviously I have to put a 2. Oxygens, I have 2 oxygens here. And I have 2 water molecules. That's also 2 oxygens. That's 4 oxygens. So I have to put a 2 at the front here to balance. Now all elements are balanced. Now we got the balanced chemical equation. In these questions, it's always good to draw the situation. So let's draw this out. So we have 1 CH4. So carbon and 4 hydrogens like that. Then it combines with 2 molecules of oxygen. Oxygen, double bond oxygen here and another molecule there. And they produce carbon dioxide, 1 molecule, carbon, double bond oxygen, same thing here, plus 2 molecules of water. So H2O like that. Now let's count them and see if the balancing is okay. 1 carbon, 1 carbon, good. 4 hydrogens, 1, 2, 3, 4 hydrogens, all good. 4 oxygens here and 1, 2, 3, 4 oxygens here. See, everything is fine. Use bond energies to calculate the overall energy change for the reaction. Now, we need to think about the equation for delta H. So here's the formula. Delta H is energy needed to break bonds. Take away energy released when making bonds. Now, we need to break all of these things. These bonds are broken, and these are the bonds that are made. Now, usually, to explain this in a more simpler way, I tell my students to think about this as if they are made of pieces of Lego. So this C is a Lego, and you have 4 hydrogens connected to the C. Then you have 4 pieces of oxygen, Lego with the letter O, and the 2 of them are connected, the other 2 are connected. If I give this to a child and say, I'm giving you this, can you make this using what I've given you? So obviously, the very first thing that the child will do is break all of these existing bonds. The child will break all of these things because he or she now knows I need to change it. So that's what exactly happens in a chemical reaction. So these bonds are broken. These 4 bonds, the green ones, needs to be broken. So what are those? Those are carbon-hydrogen bonds. Oh, here, and I know it requires 412 kilojoules per mole. Okay. Now, these 2 also needs to be broken. Now, that's the oxygen-oxygen bond, and that requires 498 kilojoules per mole. So, let's try to substitute this. Energy needed to break bonds. So, 412 multiplied by 1, 2, 3, 4 of them. 4. Add 498 multiplied by how many? 1, 2. So that's how much energy you need to break this. Take away energy released when making bonds. Now, you need to make carbon double bond oxygen, 2 of those. So that's this one here, and I can see it's 805. You also need to make 4 OH bonds in water, and that is 463. So energy release, so 2C double bond O, that's 805 multiplied by 2. Add OH bond is 463, and I have 4 of those. So all I need to do it now, put this exactly onto my calculator, like this. So the answer here is negative 818 kilojoules per mole. Again, this is another common mistake that sometimes students do. They just put kJ, kilojoules, and they forget the per mole bit. But if you look at here, that's given in kilojoules per mole. So we are going with the same units. Now, state whether the reaction is exothermic or endothermic. So if you just remember the fact that if it is a negative value, this is exothermic. If it is a positive value, this is endothermic. If you remember that, just use that one. That's fine. So here's the idea. Now, how do we find our overall energy change delta H? Energy needed to break bonds, this one, from which you take away energy released when making bonds. Now, when you get a negative answer, that's because the bit that you took away is larger than the first number. That's why you get a negative answer. So something small, take away a big value, will give you a negative answer. What does that suggest? The energy released is bigger than the energy needed. So overall, it gives out energy. That's why if something has a delta H value that is negative, it is exothermic. So you can write this exothermic. Very popular GCSE exam question, and it's very easy to get full marks. But usually it's a good idea to do the calculation twice just to make sure that you get the right answer, because you can miss a small 2, you can miss some multiplication, you might mistype something on the calculator, things like that. So be careful with that, but provided you do that, it's actually easy marks.